Now, all quadratic sequences are related to the square numbers. Square numbers are 1, 4, 9, 16, 25, etc. So when we're trying to find the nth term, it will have somewhere in its formula n squared, which are these square numbers. So it's very important that we know the square numbers, because we're going to be constantly comparing the sequence we've got to those square numbers. So let's look at a sequence. So this sequence from 11 to 20 has gone up by 9, 20 to 33 has gone up by 13, then 17, and then 21. If we look at those numbers, they're going up by 4 each time. Now that number tells us something about the square numbers we want. So we're going to look at the square numbers. We're not going to look at just the square numbers, we're going to look at 2 times the square numbers. And the reason I've chosen 2 is because it's half of 4. So 2 times the square numbers. So the square numbers are 1, 4, 9. Double those. So double 1 is 2. Double 4 is 8. Double 9 is 18. I only need 3, that's fine. Then I'm going to go back to my original sequence, which was 11, 20, 33. And I'm going to see how close I am to my original sequence from my guess that my sequence is 2n squared. So 2n to 11 is add 9, 8 to 20 is add 12, 18 to 33 is add 15. Now if I look at these blue numbers, 9, 12, 15, they're going up by 3s. And this is a sequence that I can find its nth term from, because it's going up in 3s, so it must be 3n. But it starts at 9, 3 add 6 gives me 9. If I combine my square number part with this extra part, I've got the nth term for the whole sequence. So the whole sequence is 2n squared plus 3n plus 6. So it's quite a long process to work out the nth term. Let's look at another example. So we start off by saying, what's the sequence going up by? So 12, 14, 16, 18, and we look at those numbers and say, what are they going up by? Which is 2 every time. We know it's a quadratic, so we know we're going to compare it with the n squared, with the square numbers. But how many? Well, it's going up by 2, and half of 2 is 1. So I'm going to do 1 times the square numbers, which is 1, 4, 9. Now the sequence we've been given is 15, 27, 41. So how do I get from my square numbers to my actual sequence? So I'm going to 1 to 15 I add 14, 4 to 27 I'm adding 23, 9 to 41 I'm adding 32. So let's look at that blue sequence of numbers, 14, 23, 32. It's going up by 9, so it's 9n, but it starts at 14, so I need to add 5. Then I can combine my square part with this extra part, and that gives me the whole nth term for the whole sequence, 1n squared plus 9n plus 5. Okay, let's look at one more. So from 11 to 21, add 10, add 12, add 14. Those numbers are going up by 2. Half of 2 is 1. So I'm going to look at 1 times the square numbers, which is 1, 4, 9. Now my sequence was 11, 21, 33. How do I get from the square numbers to my sequence? Well, I'm adding 10, then 17, then 24. Of those blue numbers, they're going up by 7, so that's 7n, and they start at 10, so it's 7n plus 3. Then my whole nth term is 1n squared plus 7n plus 3. We'll do one last example. So 12 to 30 is add 18, 30 to 54 is 24, then 30. So these numbers are going up by 6. Half of 6 is 3, so I'm going to want 3 times the square numbers. So 3 times 1 is 3, 3 times 4 is 12, 3 times 9 is 27. Then I compare those to my original sequence of 12, 30, 54. To go from 3 to 12 I add 9, 12 to 30 I add 18, 27 to 54 I add 27. So looking at those blue numbers, 9, 18, 27, they're going up by 9s, and they start at 9, so it's 9n plus 0. So my overall nth term formula will be 3n squared plus 9n plus 0.